Hey class, Mr. Henry here with the second half of this lesson on distance time graphs. So in the first video, we watched a motion time graph of a person being shot upwards out of a cannon and then falling, and then their parachute deploying, and then the rest of their motion from that. So I want to talk about a couple things related to distance time graphs in this video. First off, let's talk about the axes of a graph. In a distance time graph, our two axes will be distance and time. Starting with time, time is what we call our independent variable. You might remember that term from when we covered scatter plots. The independent variable is what will be on the x-axis. So we will have time down here on our x-axis. The y-axis is used to represent the distance because distance is our dependent variable. So our dependent variable is the one that will be on the y-axis. So in a distance time graph, we will have distance up here on the y-axis. So any distance time graph will look like this. We'll have the distance on the y-axis and our time here on the x-axis. Let's also talk a little bit about speed, because as we noticed in the video, in the previous video, that when the speed changed, a feature of the graph changed. And what really changed was how steep the line was. So if we're looking at a distance time graph, how steep a line is will tell us how quickly something is moving. So start off with the steepness of the graph will give us some information about the speed. So if we've got a very steep line versus a not so steep line, the one that is very steep will represent something that is moving fast, and the one that is not so steep will represent something that is slow. So the steeper the line, the faster the speed, and the less steep the line, the slower the speed. Sometimes in a distance time graph, we'll see something that looks like this. We're moving along, and then there is a horizontal part. And then maybe it keeps moving on after that. If we ever see a part of a distance time graph that is horizontal, that means that the distance is not changing. Remember, distance was on this y-axis. So this is our distance here. If the distance is not changing throughout this whole point of the graph, that means we're not moving. So the object was stationary. Or in other words, the speed is 0. Right? That means it's not moving. If the distance is not changing, then it can't be moving. In the previous video, we saw a graph that looks something like this, where we had a curved part, and then we did also have a part that was a straight line. So if we have something that is a straight line, or we would say linear, so linear means that the graph is a straight line. So if something is linear, that means that the speed is constant, meaning that the speed does not change. In the video, this other part of the graph represents when the man in the rocket was being shot up into the air. So down here, he started off pretty fast, right? That's why the line was very steep. And then as we go, it starts to get less steep. So you can see he's slowing down, right? He slowed down until he got to the top. And then he started picking up speed again on his way down. So if you see something that is curved, that tells us that it is non-linear. Essentially, that just means that the speed is changing. All right, let's quickly take a look at an example. So in this example, we are asked to describe the motion in this graph. So essentially there are 3 parts. So we start here, and you can see we've got this first part that is a straight line. So let's call that part A. We also have this part here from here to here, which we'll call B. And then the last part is this part that appears to be curved. We'll call that C. And so if I wanted to describe those, The first part, A, we can see that it is, first off, it's a straight line, so we've got a constant speed. And because that this line is moving downwards, this tells us that the distance is getting smaller. So if I'm trying to measure how far something is away from me, but that distance keeps shrinking, that means it's getting closer to me. Here it starts at 8, so the object starts 8 meters away, and then it is now 4 meters away once it gets to this point down here. So that means it is moving towards us at a constant speed. The next part here is part B. In part B, we've got a horizontal line. So as we just discussed on the previous page, if we see a horizontal line, then it is not moving. So I'm just going to say no movement. I'm also just going to say the speed is 0. The last part of this is part C. So you can see part C is nonlinear. That means the speed is changing, but let's look at the steepness. First off, it starts out not as steep, and then it gets steeper. So if it's getting steeper, that means it is getting faster. So moving towards us. And I'm just going to say it's getting faster. So distance time graphs tell us not only where something is and when, but it can also tell us how quickly something is moving, and whether that is moving at a constant speed, or maybe it's not moving at all, or maybe its speed is changing. And that's everything we need to know about distance time graphs for today.